to our channel. My name is Teacher Smith, and today we are going to understand a very interesting principle on counting. So to understand the principle well, I have taken a question from the past year SASMO 2024, question number 23. So let's just dive into the question to understand about the principle. Here the question says, how many different three-digit odd numbers can be formed using an odd number of matchsticks in total? So firstly, what the question is saying is, we have to find how many different three-digit odd numbers. So there will be a three-digit odd number that is present, and how many different odd numbers that we can find in such a way that we have to use the digits from here, that is from 0 to 9. And if you pay attention closely, from 0 to 9 there are digits which is made up of some matchsticks, and the number of matchstick is different. Some matchsticks are even and some matchsticks are odd. So I have to find out this three-digit odd numbers in such a way that the total number of matchsticks that are used to make this three-digit should be odd. This is what the question is asking. Now, first of all, to make the numbers to be odd, first we need to understand how we can first find out odd numbers. That how many odd numbers I can form from these digits that are present. First, we have to find out that. No worries. First, let's have an example to see how we can find out the numbers that we can find from the digits. So, let's say if I have some digits like 2, 3, 5, 6 and 8, and I need to find out how many numbers that I can form. Two digits numbers that are odd. So, I need to form two-digit numbers, right? Now, in order to form two-digit numbers, how I can be assured that a number is even or odd? How can we check? Yes, we have to pay attention on the last digit. The last digit of any of the number. If this last digit is odd, then I can say the number is odd. If the last digit is even, we can say the number is even. So currently I have to form odd numbers. So which digit do we want? Yes, only odd digit. So out of all the five digits, which two digits are odd? Yes, it's just 3 and 5 that is present. So the last digit either should be 3 or it should be 5. So which numbers that we can form? Any guesses that we have? Oh, the very first digit is 2 that is present here. So I can pair this 2 with 3 and 5 to form two numbers. So it can be 23 or it can be 25. So you can see I have formed a two-digit number. Now, is this the only combination that we can have? No, the only condition is 3 and 5 should be at the last place. So at the first place, I can again put 5 and 3. Now, why I can't put 33 and 55? Because the question says should be used only once. So that is the reason why the other two numbers will be 53 and 35. Now, apart from this, 3 and 5 should be constant at the final place to make it as odd number. So at the front place, which other digit I can put? Yes, we can try with 6. So I can have 63 and 65. And lastly, we have 35, 3 and 5. So the last digit I can put is this 8. So I can get 83 and 85. So in total, how many numbers we can form? Yes, the two-digit numbers are nothing but just 8. Now just imagine if I have a lot of digits that are present. Imagine a lot of digits. Am I going to list down each and every number to find out? Will be very challenging, right? It will take a lot of time. So let's see what is the shortest way in which we can get the answer. That is 8 without even trying out, without even listing. So let's just. So basically the condition is what? I have to find two-digit numbers where the number should be odd. So which digit we have to pay attention on? The last digit, right? The last digit should be an odd digit. So out of all these 5 digits, how many digits I can put at this place, the last place? Yes, it can be either 3 or it can be either 5. So how many digits I have? Only 2 digits. Now, at the very first place that is here, which digits I can put? You can observe, right? Even if I put 2, it can be paired. Even if I put 3, it can be paired. Even if I put 5, it can be paired. Even if I put 6, it can be paired. Even if I put 8, it can be paired. So, I can pair all these digits that are present in here with the other digits. But, there will be some repetitions that are present. So, how many digits that I can actually put out of all? Yes, because one digit is already put here. So can I put all these 5 digits here? No, right? So out of all this 5, we can only put 4 of the digits. And when? How to get the answer that is 8? So each of the digits can be paired with the other digit that is present here. So if it can be paired, one digit 2 can be paired with 3, it can be paired with 5. So what I can understand, one digit can be paired with 2. 4 digits can be paired with how many numbers? Yes, in total of 4 times 2, that is 8. So the operation that we have to use is times. So what we can understand is just two things from this question. One, regarding the number has to be even or odd. Which digit we have to check? Yes, we have to check the last digit. The last digit determines if a number is odd or even. The second thing that we can understand is, in order to find out the list of numbers, we can count each place possibility, like the last digit, the first digit, and so on. We can count each place possibility to find out the total number of ways. And at the end, we have to multiply. So this is how we can form numbers. We can find out the numbers just by using the digits. Now understanding this, let's jump onto our question. But our question is slightly different. It's based on 3-digit odd numbers. So I have 3 of the places to fill. But the condition is the same. It should be an odd number. So for odd, which digit we have to pay attention on? Yes, the final digit. The final digit has to be an odd digit. So, how many options do I have to put at this place that is present? I want to get the number to be an odd number, right? First. So, to get an odd number, how many options do I have? I can either put 1 that is present, I can either put 3, I can either put 5, I can either put 7, I can either put 9. So, in total, how many options do I have? We have 5 of the following options. So here it can be any of the number that is present. So in such a way I can be assured that the number is odd. Now regarding the very first place, how many options do I have? Here the question says I can use digits from 0 to 9. We can observe from 0 all the way to 9. But can I use all the digits from 0 to 9? That is 10 digits. Can we use? Of course not, right? If I put, let's say, 0 in here, is it possible that I'll get a 3-digit number? No, right? 0 will make it into 2-digit number, which is not possible. So I can only put digits from 1 all the way to 9. So what we can understand here is, here we can only put 9 of the following numbers in order to get the number to be odd. Now the main question arises is the middle digit. What should be the middle digit in such a way that I have to satisfy the condition of total number of matchsticks should be odd. So the number of matchsticks should be odd. How we can calculate this? Because here, if you check the list that is present from 0 to 9, there are different matchsticks that are used. There are two types of matchsticks that are present here. One is even number matchstick, second is odd number matchstick. So let's just first classify, let's just first see how many even number matchsticks do I have. Now, regarding the even number of matchsticks, let's say if I start from the very first digit, oh my bad, that is 0. So regarding this 0, how many matchsticks do I have? Let's count. 1, 2, 3, 4, 5 and 6. So it's 6. So which place it will be? Will it be even number matchstick or odd number matchstick? Of course, it will be even number matchstick, right? So instead of even, I'll write down first odd number of matchstick, then I'll put 0 here. Now regarding this 1, let's just check. It's 1 and 2. Oh, 2 is an even number. So again, 1 belongs to even number matchstick. Now regarding this 2 that is present, which category does it belong? Let's count. 1, 2, 3, 4, 5 matchstick. 5 matchstick means odd number of matchsticks. So I'll put 2 in odd number section. Now regarding this 3, let's count. 1, 2, 3, 4 and 5. 5 odd number matchstick. I'll place 3 at odd section. Then 4. 1, 2, 3 and 4. What a coincidence. For to make 4 matchsticks. So 4 is an odd number. I'll put, 4 is an even number. My bad. So we can put it in the odd section. Even section. And lastly, I have 5 that is present. Now regarding the 5 that is here, let's count. 1, 2, 3, 4 and 5. So 5 is an odd number. I'll place it at the odd section. Moving on to 6. 1, 2, 3, 4, 5 and 6. 6 number of matchsticks which is even. So I'll place it here. Now regarding 7. 1, 2, 3. 3 matchsticks odd. Then 1, 2, 3, 4, 5, 6, 7. Oh, it's an odd number of matchsticks. So 8 belongs to odd. And lastly 9. 1, 2, 3, 4, 5 and 6. So the number of matchsticks for 9 is 6, which is an even number. So 9 belongs here. Now, here let's check. There is 3-digit numbers that are present. Where this 3 digits that I have listed, that is here. The last place is already odd. I need to make sure the sum has to be an odd number. Now regarding this 9 digits that are present here. This 9 digits I can put anyhow, right? It can be any of the number that is present. So this number can either be even or this number can either be odd. So I have 2 of the following odds present. But I need to make sure this number has to be odd. Now the question arises for the middle term that is present. So let's say for the middle term, what are the possibilities that I have? Now, if one of the number is even, the other number is odd. How I can assure that the sum has to be odd? How I can be assured? Which digit this should be in order to make sure it is an odd number? Yes, we can put only even here. So if I put an even number that is present, even number of matchstick, then I can be assured even number matchstick, odd number matchstick will give me a total of odd number. This is one possibility. Now, if I have 2 of the odds already present, and the sum should be odd, so which digit I can put here? So it can be either odd. Odd and odd. Very good. It should be odd that is present. So regarding the middle digit that is present, this middle digit can be either even. This middle digit can also have odd number of matchstick. Now let's just check for the very first case that I have very pointed out. That is first case. First case says each should be a even number matchstick. Now even number matchstick, how many possibilities do I have? I can only put 5 of the numbers that are present. Now regarding if it's odd, how many options do I have? Oh, again it's the same. It's the same, that is 5. So even if it's odd, even if it's even, I can still be assured that the digit that I have to put here has to be 5. So the number of possibilities just is 5. So I'll replace this with 5. Now, in order to find out how many total numbers are there, which sign should I put in the middle? Yes, it should be multiplication. And when we multiply, we can get the final answer. So, the total number of matchstick that we can get is nothing but 9 times 5 times 5. So, there will be in total of 225 numbers that we can form in order to make sure it satisfies the condition. So, what we can understand from this question here, we had to find out an odd number of matchsticks. So the total number had to be odd. Where we didn't care what the last digit is. The last digit had to be odd because the question was about odd. But even if we didn't care about the last digit, even if we didn't care about the first digit, the only thing we cared about the final place. That is, it should be either even, it should be either odd. So whenever you want to find out the total numbers that are present, it is only dependent on the final stage. That is the last stage. And the last stage here said it can be even or odd. So this will be the summary for this question to remember. to make sum of numbers to be either even or odd. It actually depends on the last step. So this is what we can understand from this question. Now, if you have any of the doubts or more other questions on this, you can scan this QR code. This is our P2 P4 study group QR code. Here you can post your doubts. I will solve it personally. So that's my time, and that was the explanation for the question. I'm Teacher Smith signing off right now, but I'll see you in the next video.